So today, basically, we're gonna add a query parameters parser. I think that's the next most important thing that we need to do for like a minimal working HTTP server. And the reason why we need this is because request lines include the query parameters as part of like this. It's basically this part, which contains the path name and the query parameters. And if we want to match on basically allow users to do something like this, similar to what you do or what you see in Node.js or Python to define custom routes. We need to extract this part out separately, and we need to parse these as well, so we can pass them into the handler of the route. So very important thing to implement. And also made a list of all the things, I think. Not all the things, but the things that I'm thinking about right now that we need to implement. So this is I just mentioned. Second thing is adding supports for defining routes. This comes after. Adding code to construct responses. This one isn't like well defined, so I might remove it or maybe add more details later once we get to it. Implementing concurrent request handling using threads or asynchronous I/O. This will be very interesting. I think this one is the most difficult for me because I have no experience in these things whatsoever. Neither like threads or asynchronous I/O. I've only worked with it like once many years ago. Then we could build middleware, serving static files, and then parsing and constructing request bodies. I may have missed like a few things here and there, but once we, move down the list, if there's anything that we forgot about that's essential, we'll just work on it. Yeah, so we're gonna do request parsing today. As you can see here, I was having a conversation with Claude about the format of query parameters, and apparently they don't have like, there's no limitation on what you can have. You can have I think the example is here. So empty keys are allowed and empty values are also allowed. So we need to account for all of that. It should be up here, yeah. So empty value, we only have a key. We could have keys with no equal sign, which we need to support as well. A value with no key. And a completely empty parameter, so neither a key or a value. I'm not sure how we're gonna parse that or what's that gonna look like in the output query parameters. And just a question mark. I think we should list these or write them down somewhere. So let's put them here. Query params parsing. What else? Yeah, then we need to worry about encoding. I think this might be a step 2. Initially, we'll just try to get this working. So in query parameters, if you have a key that contains like special characters, like a space, for example, I think Claude showed me a good example here. Yeah, it's this. So special characters. This is what what's it called? Encoding, percent encoding. Yeah, solves basically. So let's say you have a key called search, and then the value is dogs and cats. You can't put spaces like this in the URI section of the request status line because it's not even the spaces, it's the ampersand actually, because this is supposed to be a separator between different query parameters. So you need to encode it, including spaces as well. You need to include the spaces, encode the spaces, and encode the ampersand. And this is what it looks like encoded. So dogs, the 20, I think, is the space. We can look at I think the encoding is basically ASCII. So 20 in hex. Where is it? Yeah, it's a space, as you can see. And then we have 26, which is the ampersand. So we can support this later. So when parsing requests, we need to parse these parts as well. And it also goes even further. You need to support Unicode apparently. So yeah, I think this name Jose or something. Not sure how to pronounce it correctly. Yeah, you need to support Unicode basically. The E with this thing on top. I'm not sure what it's called. This consists of 2 separate percent encodings. So yeah, lots of stuff. I didn't think this. I thought this would be simple, but apparently it's pretty tedious process to, you know. Hopefully it doesn't take too long to implement all of this. And I already wrote some structs and function definitions for parsing query parameters. I was recording, but I lost. After I finished the recording, I found out that the screen was frozen, so I had to basically do everything over. But we basically have an HTTP query param. These I think will be null terminated. Actually, let's ask Claude, can query params, keys, or values contain null terminator or null bytes? Yes, they can be represented. Oh, the spec doesn't specifically prohibit it. So this is not a problem if it's in the percent encoding format, but once we decode it, this will cause problems. We can't rely on null terminators to know the end of the key and the value here. So I think we might also need to store the length. So now I'm thinking that maybe we should add a string implementation. I haven't done this before, but maybe we could implement our own. Let's see what it looks like. So string clone. I want a simple one. So let's add a simple string implementation, I guess. Why not? We don't care about security right now, or like overflowing buffers or whatever. So so we're gonna have a max length and a length. And data of max length. Does this work? No. Let's try this. String create, yeah. String destroy, string append, string prepend. I don't want to implement like extra stuff that I don't need. Let's just do append right now. String append char, sure. I mean, this one is useful. Oh, these need to take the length, so pretty important. String prepend. What else do we need? Don't we need like an iterator or something? So string create. I don't want to use mallocate here. I want to use my arena. How do I make my string implementation at independent of the memory allocator? I want it to use arena, this project, but I want to keep the code generic so that I can copy it into other projects where arena may not be present. Let's see. Pass allocator functions directly to your API. This is too complicated, I think. Accept an optional allocator context. Define a struct with function pointers. No. Through macros. Initialization function. What's the mostly used practice for something like this? So just fuck it and add an arena argument. The mostly used. It's the most used is what I meant. What if I pass arena as null? And in that case, it would use malloc instead. Let's add arena. So size of string. Let's just use arena for now. I don't like calling this string. We'll call it earring, because why not? So basically size of earring plus max length plus 1. Why the plus 1 here? We're not going to add a null terminator. If it wasn't allocated, we return null, sure length, max length, and we don't worry about no null terminators. Destroy we don't really need. Append we need though. So suffix and suffix length. If stir.length plus suffix length is bigger than the max length, not enough space, then we copy basically the current length plus I. Yeah, this looks good. Let's do append char as well. And let's do prepend. I know I said that I won't be using AI to write code, but these functions are pretty simple and they're just time consuming to write manually. So why not? And I'm even going over the code and checking that, you know, everything is correct. So prefix length, this is pretty much the same as this one. Oh, we need to shift though. Oh, I see. So we shift right, then we go, so we right on the left. I think that works. Now we can go to our HTTP query param, and this now can be string earring, sorry. We should probably add utility functions for these. Same thing with like we have with the headers. So let's do int HTTP params. What's it called? Add. Takes a params, takes a key, and it takes a value. Do we have clear? Sure. What else? Query params. Let's implement these functions on demand. We don't need them right now. I think we only need add. Maybe delete too. But I wonder what the behavior should be, since we have them in an array. So I think if you delete a param, it should delete like all the occurrences, right? This doesn't need to return anything, I think. Headers delete. I just realized something. Should delete all occurrences of the key. Completely forgot about that. It returns the index. Yeah, that's not gonna work anymore. I don't like this, what I did with the HTTP headers parser. So I'm just gonna return void for clear. Or maybe it should return the number of deleted items. Is that ever gonna be useful? I don't think so. So add doesn't need to return anything either. Or maybe it does to indicate errors. I don't know, man. These things are confusing. I'm wasting too much time on this. I think this should be done here. It has a length and an array. Yeah, but we can't treat query params the same as headers, because headers have a max length, but what about query params? We'll just impose a limit, whatever. I think 100 is good. Maybe let's do 500, why not? I mean, it doesn't really hurt. You know, other than that we have to allocate a big chunk of memory for storing the pointers to them, which is not much. Query param times query params. Yeah, this looks good. Let's just put them here. I don't like that I'm using two structs for query params and I'm only using one for the headers. So we'll just use one here. So it's going to be keys. Size of earring pointer. Keys and values. This looks good. I mean, sure. Let's take a look. We do string create. We should pass the arena. So with the headers, we don't actually allocate memory, we just copy the pointer. But with these, we do allocate memory. I think that's fine. Let's pass arena here. Then we do string. We should probably have a string set function. Let's implement it. I mean, sure, whatever. I think I lost some of my changes here. Do I have anything in the stash? I don't. This wasn't like this. If I remember correctly, or was it? I think it should be like this, right? If it's not okay, then we check for all of these. And then we panic. Then we check the length. I fixed this last time, but I lost the code somehow. And we do the same thing here. Does the code still run? It does. So right now I think we only need to add. I'm thinking maybe we should also convert the keys and values in HTTP headers into our string implementation, or to use our string implementation. Can headers, I've asked this question before to Claude, but I just want to confirm. Can HTTP headers contain null characters, either in keys or values? Okay, let's just keep it as it is then. So HTTP query string parse, we need to implement this. So this takes in a query string. No, it should take the headers structure, right? Or maybe the connection? No, it should take the request struct. Actually, no, I think this is fine. And what does it return? It needs to take in arena as well. It returns an out params. It doesn't return it, it just populates it. This will be int for now. We'll change it in a bit. I'm not sure what the errors are for parsing query string parameters. So what do we need to do here? Actually, let me go to request real quick. We want to add something here. So we will have a path name only that will be populated by this parse params thing. Maybe we should have a function that parses it. I'm not sure. No, I think it should be done separately. So what this will do is, let's do int I is 0, while, nope, while query string I does not equal question mark. I'm thinking maybe we should have a separate function that splits the path name from the query string. I think we should do that. We will extract the path name. Yeah, I mean this is good. So it takes in a request target, which is the entire string. Stirs chr, what does that do? What is stir dup? Is it duplicate? Can be freed with free, no. We don't want to do that. But yeah, we can just return a pointer to it. Or we have to allocate it, I think, with the arena. Why is this a double pointer anyways? Oh, so it can set it, I see. So how is this gonna work? We have out path name. Takes in arena, request target +1. But then we need to copy. Yeah. Into our path name, we copy request target. No, stir in copy. And it takes in the length of request target. No, this is completely wrong. It's gonna be query start. Oh, which we didn't find. Never mind. Yeah, it is correct. So it's gonna be request target +1. Then we can do request target len. Let's just store it here. We add one so we can add the null pointer. And now we can do this, yeah. And no query string, basically. We return 0. Let's just return void. So path name length is query start minus request target. Which I think is correct, yeah. So request target length minus path name length -1. Oh, this is the query string length. Okay. Yeah, that makes sense. So here we need arena, path name length, and then query string length +1. We copy. Why are we doing mem copy? Yeah, I think this is good. It will be query string parse request. I think this should be here. Where is it? You come here and get up here. I think we should have it to the have it in the header file. So this should populate them. And then what we can do is parse query parameters. We pass arena query string, and this should be query params. Let's see first if this works. Let's go to main.c and print them as well. What's the full path? Request target. I keep forgetting the name. Path name and query string. I think it's gonna segfault here. So it did work. and I also printed the query string. But what happens if we don't have a query? Failed to parse request. Why? Oh man, it's Vim doing its thing again. It keeps removing my 0Ds. Like, this is actually annoying that I can't edit binary files. What was it called? No URL. Set no URL. Question mark. No end of line. Set binary. It is binary already. Can you give me... so I did some research and apparently I can just use printf here. How do I use printf in the command line on Linux to create a basic HTTP request with proper separators? Yeah. Oh, cool. This is JSON. Actually, let's just use this one. And we're gonna redirect it into our file here. I don't think we're supposed to open it. Okay, this time Vim didn't ruin the separators. Anyways. Okay, we segfaulted. That's not good. So do we have debug? Yeah, I think we do. So let's use LLVM to try and debug what is actually happening. And I think I need to install it. Install LLVM debugger. So now that we have LLDB, we can just, I think, run our server here. Press run. And we segfaulted. Read path name and query string. Don't show me notifications, please. Let's see. It's in request.c, read path name and query string. What line though? What does this 154 mean? In LLDB, how do I know which line the segfault happened at? Backtrace. Oh, list. That doesn't work. Frame info. List. And backtrace. Yeah, something happened here. Okay, let's see. Where are we actually calling this function from? It's being called from here. Let's do a debug print. Query string. Does this contain a null terminator? The query string part. Ooh, actually this is the one that sets it. So it splits out the path name. request target, we have a path name, and then we copy into them. Ooh. Oh, actually, I think I know what's happening. We need to do make debug. Now it works. We weren't compiling with debug symbols, that's why. So make debug. Let's make clean and make debug. So now we do LLDB. Server, we run, we crash. Oh, there we go. That's more like it. Request target length is path name length. Let's print here. Oh, it's failing here. I thought it was down here. My bad. I wasn't even looking at the line number. So let's see what's happening here. So we have out path name. We're doing arena allocate. Request target length. If query start is null. And then we do stir and copy. Copy into a path. Out name. Request target length. Oh, I think we're supposed to do this. We're supposed to copy the length, not +1. We're copying an extra character. So that basically leaves no room for the null terminator. And then we try to assign it. But that shouldn't matter though, because it basically overwrites it, no? It overwrites the last character. But let's test. This is definitely weird. We are going to segfault again. How do I set a breakpoint? Let's just set a breakpoint here at 222. See what happens. Break. Which file is this? Request.c. And we specify a line number. It was 222. And then we run. We stopped here. We step. Oh, I didn't mean to go into it. How do I jump over function? I think it's next or something. Yeah, it is n. Let's print. How do I print a variable? P, I think, but I'm just, making sure. Request target length. It is 9. Is that correct though? Let's do xxd. And this is basically 1, 2, 3, 4, 5, 6, 7, 8, 9. It is exactly 9. +1 for the null terminator. Which is what we did basically. We allocated memory for 9 + 1, which is 10. Then we do stir and copy into out path name. Into out path name. Request target. Let's print request target. It's API data, and then we do stirlen. How can I use functions like stirlen? Can I just include the header in the debugger? That would be funny. Expression int stirlen request target. It is 9. So if we go next now and we try to print out path name, we want to print the pointer. It is API data. So yeah, basically the reason why this is failing is because we need to do this. So we take the pointer, we dereference the pointer, which gives us the actual string pointer, and then we modify it. Basically the same thing we were doing here, but I don't know why we didn't have it here. Out query string is going to be null. Yeah, this makes sense. So now if we do make debug again, it should work as expected. And let's try something else. Let's do a printf, and this time, but actually add a query string. So where does this go? Here. Now if we do this, query string is basically empty. Now let's actually add some text. World potato \0. We run. Let's see what happens if we add a null terminator and then we add some characters after. Yeah, it stops printing. But I forgot actually. So last time when we asked Claude, according to the HTTP RFCs, can query strings contain null terminators? So by default, I don't think so, because if you have a null terminator, you have to %escape it, which is basically doing this. You have to add the %, and then 0, I think. How do you... Actually, we can just check in the console here. So if we do encode URI component, and do this, \0, yeah, it encodes to 0, %00. So we're not gonna have like a real null terminators. A null byte would be encoded. The key points in the raw URI on the wire, you won't see an actual 0 byte. It would be %encoded. Okay, so we don't have to worry about it. It's not a thing. After decoding, if you decode 00, you get a null byte, which is valid. So, and I think based on what we researched last time, if we go to request.h, I think that's why we decided to use a string implementation for the query parameters, because the keys and the values will be parsed. When we split them, we basically have to decode these %encoded characters. But in the raw query string, we don't have to worry about that. So a null terminator is something that we won't expect, I think. But what happens if we do have it anyways? Or maybe someone like sends in a space character here. And yeah, the parsing fails, which is exactly what we want. So potato is equal to 5 and hello is world. We take a look. As expected, this is working. What happens if we remove this? Query string is null now, and this is all part of the path name. Amazing, this works fine. So the next step is basically to go over the query string, you know, like parts, and split them by, you know, the ampersand, decode them, and store them in this structure that we have here. There we go. It's this one. Let's add a comment. So basically splits the request target into path name and query string. Allocates memory for path name and query string in the given arena. Don't care about this. So now we're gonna work on this next. And I'm wondering maybe we should split these like into files. Like for example, parsing the request line should be in a separate file. Parsing the headers should be like all the functions to parse the headers should be also in a separate file. And same thing for query string. But for now, I think this works. So we're just gonna continue writing stuff here and then we can split them later. Okay, so parses the query string into key value pairs. Yeah, string parsing is lovely. So what do we have here? We have the query string and we have the out params. Is the query string null terminated? I think so. So, okay. So let's do this. We have size t, query string length, exactly. Do we wanna? Yeah, sure. We initialize a counter. And we have out params. What was the structure again for the query params? Okay, we have maximum of 500. So does the header, the function that adds headers, take into account the limit that we have set? I wonder. Oh yeah, it does. Okay. Okay. To make sure to check for the limit. What is this? I've never seen this before. Okay. So how do we want to do this? Let's look at a few query string examples here. I think I wrote them here somewhere. So we could have this. So I think we're already removing the question mark part, right? So if I do this, let's just compile and run. What is happening? Oh, we're segfaulting. Wait, didn't we fix this? Why are we segfaulting? Oh, because query string might be null. So in that case, yeah, I think that might be why. Yeah, it is. Let's do printf again, but actually do this, rerun. So now the query string is this. Yeah, so it does remove the question mark. So now, I guess for the examples, we can remove the question mark. We could have this. That's, I guess, one example. We could have this, just the key. It could be like this, I guess. Maybe let's not add the ampersand for now. It could be only the key without the equal sign. And it could be just the value, completely empty. So this. I guess let's just start with the best case scenario, which is having both a key and a value. And then we'll go from there, you know, and try to handle the rest of the edge cases. Okay. Find key. We could just use stir TOK here, I think. What does... we used it last time, but I forgot. Oh. So it modifies the original string. Is there a version that doesn't modify the input? So we used memCompare last time. Does that also modify? Okay. Well, let's just do manual checking, I guess. So we find the key, key start, and key length, and then what does this do? I is less than query string length, because we're advancing, and we don't want to overflow here. Query string, we check the current character. If it's not an equal sign, it's not an equal sign, and it's not an ampersand. Okay. If I is bigger than or equal to query string length, is this so we can break early, I guess? Okay. So I think what we're checking here, so the first part checks if we're already at the end, which means that there's no value, so we only want to store the key. And the second part basically checks that, you know, so here I think when we were building up like the length of the key by incrementing key length, we were checking that we basically keep reading or incrementing until we reach an equal sign or an ampersand. But here we're basically checking that the character right after the key that we just read is not an equal sign. If it's not an equal sign, then that means it's an ampersand, and that which basically means that this key does not have a value. No value for this key? Sure. Okay, what the? Add key with empty value. That's not how we want to do it. So this is supposed to be an earring. And string create, exactly. I don't think we used, did we? Bear, do we have bear installed? We don't. Okay. So key. Yeah, I don't think we need to worry about the overflow here, because we're passing in key length to both the allocation and the copying part. So there's no value. I think. Empty value. But do we want to like create a string for empty values? I think we should just leave them as nulls. Where's the add header function? Okay, let's add more functions here. So we have delete and oh, there we go. Oh, we have a function that takes care of this. Okay. So if key is null, or if key is not null, and here if value is not null, so I think we can do this. We can initialize them with null. Same thing here. Oh, yeah, I think this makes sense. So now we go up. Parse, what was it called again? There we go. So I think here we can just call query param add, pass in arena, params, where does that come from? I think out params. Then we have the key. Oh man. I think we need to pass in the length as well. Like of the key and the value. Because otherwise we would have to create a new string and null terminate it, so just so we can pass it to this function, HTTP query params add. And I don't want to do that. So let's also accept key length and value length. Let's go to the header and modify it. Oh, I can just copy from here. Do this. We're not gonna do strlen again anymore. It's gonna be keylen, and we're gonna trust that the caller passed in the correct length. And here is gonna be value length. This looks good. So arena, out parameters. So key. Key in this case is query string key start. I don't like this. What if the key is also empty? So here we're consuming the key, right? We have value start, value length as well. Let's do another while loop. This is the same check. And query string is equal to... Oh, actually there's one more thing. Check for illegal characters. In key and value. So we consume the equal sign in this case, but only if it exists. And then we try to consume the value. And how do we do that? We check for two things, that we didn't reach the end and we didn't reach an ampersand. And if value length is 0, isn't it safe to just do this? I think we can copy these here. So value start is just going to be I think. So we increment I and we increment value length, as long as we don't hit an ampersand. And then I think we're done. We basically consume this, yeah. So arena out params. Okay, so this part, we can't do this query string key start because we may not have a key. So we need to check key length is bigger than 0, then we pass in key start and key length. But otherwise it's going to be null. And we basically add it. We consume the ampersand and we just keep going. So this function now needs to also parse. Okay. Let's add it to do. Parse and decode percent encoded characters, yeah. And I guess, and maybe discard illegal characters, yeah. It should check for both. Well, we can implement this in a second. So here we can consume the ampersand. And what should this return again? I guess, like, should we really return anything from this function at all? So what does header, add header return? Returns an int. Oh, okay. Which is basically the index at which the thing was added. But what about the function that parses the headers? Where is it? Parse HTTP headers. Okay, so it returns a result. So I think this one should also return a result. But I'm not sure what kind of errors it should return. I don't think there are any errors, like when you parse query params. You're basically just parsing strings, I think. And maybe we should reject the request if someone sends in like illegal characters. Now let's ask Claude here. Should requests be rejected if illegal characters or maybe null terminators are included in the request? What is it? What is it called again? Man, I keep forgetting. Why did I open it again? I can just do this. We can go to request C. Where's the function that splits? Request target. Okay, let's see. Unreserved characters, percent encoded, sub-delimiters. Anything outside this set is illegal. What are sub-delimiters? I'm not sure what these are. Yeah, there's a whole list. I wonder if we should parse all of that. Okay. This should be parse. Parse HTTP headers. Yeah, this should be parse HTTP query string. Should return a parse result. Okay. So, I think let's actually test this thing. What was it called again? The split function, I think. Where's my split function? Or parse? Parse query string. Yeah, this is the one. So what we want to do is, let's go to main. We already have a panic here. What does the request look like? We have 2 parameters. That's good. Print. Oh. We need a custom print function, I think, for earring. What's the best way to do this? Let's rename all of these. It's supposed to be earring, 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 and earring with an underscore, of course. So now I think we need one more function. Earring what though? Print. It does not need an arena. Printf. Do we want to do printf? No, let's just do print. I think. It takes in an earring and it basically prints it. Let's rename the file as well. And I think we might have to go here now. This is called earring now. And if we go to request.c again. Okay. So now we go to earring. And we add the print function. Actually, it's not going to be a print. It's more like a write. I want to do something like sprintf, I think. Or what was it called? Fprintf? Yeah. Which takes in a file, which is a stream. Yeah, exactly. I think I want to do that. What's the signature for fprintf? What does it restrict? Okay. This is advanced like performance stuff. Let's just use file pointer stream for now. Where does file exist? It's in stdio. We do the same thing here. We need to import it. Okay, fput c. I think that makes sense. So now, I think we can do this. Then I think we have to do earring print. It would be nice if we had a function like, what is it called? Debug query parameters, which basically prints everything. But maybe we can add that later. For now, this will do. This is going to be standard error. Call to undeclared function. That's because we need to import the header. It's earring right. So keys and values. Actually, I think we have a problem. So what if, I think request right now, if we have an empty header, it sets the earring. I think it basically puts a null pointer in the earring, array, right? Yeah, it does. So we need to check for that. So if earring is null, then we return -1. So now I think this should work. Let's do a debug print. Does this print new lines? I don't think it does. No, it doesn't. So we can basically do this, I believe. Let's go here. Open up a terminal. We do make and run. Let's do make debug. Undefined reference. Where is this? It's in main. Wait, how though? Let's do make clean. Run again. Undefined reference again. Let's rename this. Do this. Try again. I wonder why this is happening now. Maybe we have string somewhere that we didn't. Forgot to fix. No. Oh, we have an unsaved file. Where? I see it. I think it's this one. Let's just close the editor completely. So string.c, we don't really need this anymore. So let's go to earring. We have the print function here. Oh, let's see what's happening. That's because this is supposed to be earring right. Let's go back to main. Here, I think we were supposed to debug print. Let's add a new line. So let's do a debug print of, let's say the query params section. And let's add in a couple new lines here. And let's do the same thing for headers. So we need a new line here. And let's just put a tab character here. Query params. Yeah, this looks good. Let's do the same thing here. We got a tab. And then we add a few lines at the end, I guess. This can just be panic. Yeah, testing. So these two work fine. What do we need to test next? Let's open up the README and go over each one of these and try to put them in the test file so we can test them. So what if we just have an ampersand? Like double ampersand. And what if we have one? We could have just the key. So key only. And we could have empty value. What else? And we have empty key, I guess. I think that should be all the cases.